Question 48, use the graph it right to write an exponential equation in the form f of x equals ab to the x power. So we're being asked to go from one representation, this graph, to another representation, an equation. And I can see that this is they wanted an exponential curve, f of x equals ab to the x. I think it probably would be more helpful if I considered uh, a table of values. So let me do a quick table of values here. Here's x's, here's y, and I can see that I know the 0th term, and I can see I know the first term, and the 0th term is 0.2. And then when I move to the next one, it's 1.4 above that. So my next point is x is 1, y is 1.6, 1.6. So we're talking about exponential growth here. So I'm not growing by adding, right? We're growing here by multiplication. If this was a linear function we were looking for, I would take 1.6 and subtract 0.2, and I could see, oh, this grew by adding 1.4. But that's not what we're looking at. We're looking for exponential. So I'm going to take the 1.6 and divide it by that previous term, the one that lives right next to it, divide by 0.2, and I get 8. So, and I'm going to go forward with that too. If I take 0.2 and I multiply by 8, you can see, yeah, you get 1.6. So my multiplier is fairly large, right? The value of b, right, my multiplier is equal to 8. The other thing that I know is because I was given the 0th term, I know a, right? A is equal to 0.2. So I can write this as f of x is equal to my 0th term, 0.2 times 8 raised to the x power. So that's certainly one answer that you can give. Another one, if you were to give in standard form, remember standard form, instead of using the 0th term, we use the first term. You could also write this as f of x is equal to 1.6 times 8 to the x minus 1 power. And it's just a matter of which one of these is going to create a value of 0. So if I plug 0 into the first one, right, if I put 0 into there, 8 to the 0 power is 0, so that gives me the 0.2. But if I put 0 into the when I put when I put 1 into this if I if I put 0 into this is going to be 1.6 times 8 to the negative 1, which does take me back to the 0.02. But if I put in a 1, it becomes 1.6 times 8 to the 0 power, which is gives you the 1.6. So both of these, if I was to graph them, they're identical to each other. They have the exact same outputs at the same time. So when you put in 0 in the first one, you get 0.2. If you put 0 into that second one, you get 0.2. If you put in 1, you get 1.6. If you put in 1 in the second one, you get 1.6. This one they call standard form, right? And this is what we typically do in this class, the top one there, where we're using the 0th term and x plus 1. But you can also use your first term, and instead of x, you just can put the x minus 1 up there. All right, so that's it for this question.